Yes, till now, the various possible operations, multiplication between the two operations for C2V and C3V point groups at least is clear to you. So you understood the four essential conditions which are needed by the group can be verified by means of the multiplication table. But we have not to stop here. We need to proceed further to understand molecular chemistry. And for that, some advanced study is necessary. Whichever the operations are there, the representation we need to study. When Schrödinger in 1926 put forwarded his differential equation, at that time people were very fascinated by the Schrödinger's equation. Rigorous mathematics was involved, but people were getting result. Up to diatomic systems, Schrödinger equation was okay with difficulty in the mathematics. But when polyatomic systems come, depth in the rigorousness of mathematics is very tedious. Heisenberg suggested one approximation method. That's a matrices method. With concept of Schrödinger and Heisenberg matrices idea, we could able to understand molecular chemistry. In Schrödinger equation, various operators are there. Likewise, here also we are with operators in the molecular symmetry and the group theory. For example, rotation, C31, or reflection, sigma, sigma dash, improper rotation, reflection, say S41. These are the operations. And these operations can be used to understand the molecular chemistry. And in order to understand those expressions, we need to know some basic matrices. What is matrices? Matrices is a plurality of the matrix. Matrix is a rectangular collection, is a rectangular array of numbers. Not always directly number remains, but indirectly number revealing function, number revealing terms do remain present there. For example, see here, one matrix, only one number is there. Yes, it is a matrix which has one row and one column. See the second matrix. Here two rows are there and two columns are there. Direct numbers are represented. See the third matrix. Oh, here trigonometric functions are there. But trigonometric function will reveal the number by filling the value of theta, by filling the value of angle. Sometimes x, y, z coordinates also can be used. For example, say point has a coordinate x, y, z. Then x, y, z remains a number, no? So that also can be represented in terms of matrices. In general, if I have to represent the matrix, say A is a representation for the matrix. In square bracket, A11 is a first term in that matrix. First number in that matrix. 11 represent first row, first column. See the second number there. A12, first row, second column. A13, first row, third column. Likewise, we can continue. A1n means n number of columns are present in that matrix. It is an indication of A1n. See the second row. First element in the second row, A21, second row, first column. Next A22, second row, second column. Next A23, second row, third column. Likewise, if I continue, last element, second row, therefore A2 should be there. And what is the number that's the last column represents? N. So A2n. Likewise, if I continue the rows, the last row will be AM1. Yes, means m number of rows are present in that matrix. And 1 is a column number. AM2, mth row, second column. AM3, mth row, third column. Likewise, continue. Last element in that row will be AMN, mth row, nth column. It is a general representation for the matrix. But which are the matrix as an example I had given to you? All were square matrices. Actually, more than 8 types of matrices are there. But considering scope of your syllabus, we will deal with only 2 types of matrix. One square matrix and other column matrix. In square matrix, number of rows and number of columns will be same. Whatever the general matrix I represented, its mathematical representation can be A is equal to, in matrix bracket, that's a square bracket, Aij. I and j are variables, where I can take value from 1 to m number of rows, and j can take value from 1 to n number of columns. If square matrix, then m will be equal to n? Yes. If it is equal, then only it will be square, no? In column matrix, what should be there? Only column should be there. Rows will be there. So it can be represented as m cross 1. Instead of n, 1 will be there. Now see here. A column matrix is represented. Example, x, y, z. Means coordinates, let it be, or it is signifying or few numbers. How many rows are there? 3. How many columns? 1. So what is the order? 3 by 1. Now let us know how to understand multiplication between matrices. Let me consider A as a one matrix. What are its values? -1, 0, 0, 0, -1, 0, 0, 0, 1. And B is the other matrix. See its values. B is equal to 1, 0, 0, 0, -1, 0, 0, 0, 1. Both are 3 by 3 matrices. Both are square matrices. Now I have to multiply them. So A into B, how it will be? Consider first row of the first matrix, that is A matrix, and first column of the second matrix, that's a B matrix. Now what you have to do? You have to lift this column and you have to affix there in the row, and their relative elements will be there, no? Their multiplication you need to see. Means what I need to do? Column in the B, what is that column? 1, 0, 0. That I will lift, and I will adjust it on the row -1, 0, 0. So respective elements will undergo multiplication. So -1 of the row will multiply to 1 of the column. So what is the answer? -1. Plus second element of the row, second element of the column. 0 and 0. Answer is 0. Plus third element of the row and third element of the column. That's a 0. So summation is what? -1. So here first element resultant matrix is -1. So I represented there -1 plus 0 plus 0. Now see, second element of the first row. How can we generate? Our row will be same. Column number will change. So first row of the A and second column of the B. What is there in the second column of the B? 0, -1, 0. So I have to lift that 0, -1, 0, and I have to fix, or I have to correlate with first row of the first matrix. So first element of the row, that is -1. First element of the column, 0. -1 to 0, 0. Second element of the row, 0. Second element of the column, that is -1. So 0 into -1, 0. Third element of the row, 0. Third element of the column, which column? Second column I am talking, is 0. So 0 into 0, 0. So how can I represent that the second element of the first row of resultant matrix? 0 plus 0 plus 0. Are you following? Likewise, same, first row. Which column I have to take now? First over now, second over. Now third column I have to take in order to generate third element of the first row. So what is our first row? -1, 0, 0. What is our third column? 0, 0, 1. So what will happen? I will lift this 0, 0, 1 and related elements I have to combine. -1 will come under 0. Answer is 0. 0 will come under 0. Answer is 0. 0 will combine with 1. Again answer is 0. So result is 0 plus 0 plus 0. It's the first row of the resultant matrix completed. Now for second row, I have to consider second row of the A, and to generate first element of the second row, first column I will take. To generate second element of the second row, second column I will consider. To generate third element of the second row, I'll consider third column of the matrix B. Accordingly, C results are there. 0 plus 0 plus 0, 0 plus 1 plus 0, 0 plus 0 plus 0. Now, third row of the first matrix will combine with different columns. When third row will combine with first column, you will get first element of the third row. What is that element? 0 plus 0 plus 0. Now, third row, second column. What is the result? 0 plus 0 plus 0. Now, last, third row and third column. 0 plus 0 plus 1. So what is the answer? AB is a multiplication between those two is equal to resultant matrix. Minus 1 0 0 0 1 0 0 0 1. It is 3 by 3 matrix. A also was 3 by 3. B also was 3 by 3. Now resultant matrix is also 3 by 3. Is the multiplication clear? It is very important. It's a basic aspect of the matrices. Now I inform you one more term in matrices because representing all the numbers and consideration, their multiplication becomes a troublesome task. In order to do approximation, we consider trace or character of the matrix. What is character? Character is a summation of diagonal elements of the matrix. A diagonal which is moving from your point of view, left top to right bottom. This diagonal. Summation of those elements is nothing but the trace or character. For example, I represented here one matrix. It's a 1 by 1 matrix. What is the summation of diagonal elements? So whatever the element is, it itself is the diagonal element. So what is the character? Character is represented by symbol chi. And that chi is equal to 2. Because only one number is there. Now see the second matrix. Here 2 by 2 matrix is there. What is the summation of diagonal element? 1 plus 21. 22. Therefore chi, that's a character or trace of the matrix, is equal to 22. Now see the third matrix where trigonometric functions are there. What is the summation of diagonal elements? Cos theta plus 1. So answer is 2 cos theta plus 1. So it is a character for that matrix. In future, we will understand the matrices in terms of characters. But let you know these matrices first. Is this point of trace or character clear to you? One more term I informed you. Keep in mind, identity remains one matrix. We are going to determine that. And character of identity is nothing but dimension. As like we say 3D picture or 4D, 5D, 6D dimension. So character of identity operation, character of matrix of identity operation is nothing but the dimension. Just only keep in mind. Now as a homework, I ask you one question. I said matrix is a rectangular array of numbers. But while saying, I said it's a square matrix. Rectangle and square, they're different, no? What do you think? Can square be a rectangle? You have to answer yes or no in comment box. Is question clear? Now in next part, let us see some mathematical basis necessary to understand these next coming points, representations and understanding of molecular symmetry by means of group theory.